All right, hey everyone. Today is going to be a review day. All right, we've been doing a lot of quadratics for a lot of days, even before this remote learning stuff happened. Right, we were in the midst of quadratics, and yeah, this is definitely the most intense unit in Algebra 1. There's a lot of stuff going on. So I thought today we'd use this graphic organizer to organize pretty much everything we've talked about with quadratics. And yeah, so this should be a good review, I'm hoping. And this graphic organizer, hopefully this will help a lot of you. So once you have this filled in, I'd highly recommend printing it out and maybe just using it as a reference when you try the homework or as you try problems and things like that. Yeah, there's something good. You can print it out, make it a poster, have it on your bedroom wall. Right, I know you guys think about quadratics all the time. So, in the middle here, this is our quadratics graphic organizer. So, I split it into two parts. Up on top, these are all the skills and the methods we learned to solve quadratic equations. All right, so up here, this is going to be our methods to solve quadratic equations. So we got three main methods to solve quadratic equations. All right, one that we started really long ago, right? Starts with the letter F. All right, so hopefully you know I'm talking about factoring. Right, the first way we learned to solve a quadratic equation was by factoring. So up here, let's do an example problem. And we'll solve this example problem using all three methods that we've learned so far. So the example we're going to be doing is x squared minus 6x plus 8 equals 0. All right, so let's solve this by factoring. So if I were to factor that, well, I see it's a trinomial. So x squared minus 6x plus 8 equals 0. So trinomial with a leading coefficient of 1. Right, so that's just basic trinomial factoring where we find two numbers that multiply to 8 and add to negative 6. So if I do that, what multiplies to 8 and adds to negative 6? I think it's going to be a negative 4 and a negative 2. So this factors to x minus 4 times x minus 2, and that's equal to 0. Change that to a different color. All right. Then we tee it off and we use zero product property. Right? We set each of these factors equal to 0. And we get x equals 4 and x equals 2. All right, so that was our first way of solving quadratic equations, by factoring. And of course, we learned lots of different kinds of factoring. Right? Remember, if there's a GCF, we want to factor out that GCF first. We also learned how to factor out dots, or difference of two perfect squares. I'll just give you a quick example. Right? If we had like 4x squared minus 9, right, it's kind of like thinking about square roots. So square root of 4x squared is 2x. So we know 2x times 2x is 4x squared. Right? And square root of 9 is 3. So one's going to be plus 3, one is going to be minus 3. Right? If you FOIL that out, you will get that. So that is how we factor 4x squared minus 9, or any difference of two perfect squares. And the factoring we just did, that's just normal trinomial factoring. Trinomial factoring. Right, and that was a case where a is equal to 1. And then we looked at harder cases where a was not equal to 1, right, and we had to use the AC method for that. That's when a does not equal to 1. All right, so that's how to solve that equation by factoring that quadratic equation. All right, so not all problems are factorable though, right? So we had to learn another method to solve quadratic equations. And we did that pretty recently, and that was completing the square. All right, I could write all the steps for completing the square over here, but you should have those steps already. Let's take a look. When did we do completing the square? So we practiced on lesson number 8, and we did it on lesson number 7. So if you do not know completing the square, you will want to check out lesson number 7/8. All right, if you need a refresher on completing the square. So completing the square, easiest way to solve this equation is by factoring. But if you want to use completing the square, well, let's check it out. X squared minus 6x. Completing the square, we're going to bring the constant over to the other side first. Right, then we complete the square by adding a number to both sides. So I would add half of -6 squared. So half of -6 is -3 squared is 9. So then completing the square, I add 9 to both sides. Right? Again, this came from -6 divided by 2, all in parentheses, squared. Half that middle value, half the b value squared. All right, so this becomes x minus 3 in parentheses squared when you factor it equals 1. Then we take the square root of both sides, square root, right, plus or minus, don't forget that. So we get x minus 3 equals plus or minus the square root of 1. Well, what is the square root of 1? What times what equals 1? Square root of 1 is 1. 1 times 1 is 1. Right, so adding 3 to both sides, we get x equals 3 plus or minus 1. Right, we're just adding and subtracting two numbers here, so we can actually write out our two answers. One is going to be x equals 3 plus 1, which is 4. And our solution will be x equals 3 minus 1, which is x equals 2. And is that what we got over here? Confirmed, right? Just a different method, but another way of solving a quadratic equation. Right, and what is our final method? Well, we did this just on Wednesday. A third way of solving any quadratic equation is to use the quadratic formula. All right, I sang that song for you guys. So we should all know the quadratic formula, but if you forgot it, here it is. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. That's the way you get it on the regents, but I don't like writing it that way. All divided by 2a is the same as dividing both of those pieces by 2a. All right. So to use the quadratic formula to solve our same equation, let's see how that looks. So all we're doing is plugging in for a, b, and c. Right, so that 1, that's our a value. Our b value is the number in front of the x, that is -6. And our c value is the constant, that's 8. All right, so using the quadratic formula, x equals negative b, so -6, plus or minus the square root of b squared, so -6 squared, minus 4 times a, which is 1, times c, which is 8, all divided by, like that, 2a, or 2 times 1. 2 times 1. All right, I'm going to clean it up a little bit. So x equals -6 is a positive 2. All right, I think I messed that up on Wednesday's notes. I forgot to do double negative, make it positive. right? So just be careful with that. Over here underneath the square root, negative 6 squared is 36. Minus 4 times 1 times 8 is minus 32 divided by 2. All right, 6 divided by 2, that's 3. All right, this is the reason I like writing it as two separate fractions, because now we can clean that up. 6 over 2 is 3, plus or minus the square root of 4 over 2. All right, I'm going to do 2 steps in one here. Square root of 4 is 2, so I'm just going to make that 2 over 2. And 2 divided by 2, of course, is 1. So we're getting x equals 3 plus or minus 1 here. And isn't that what we got over here? X equals 3 plus or minus 1. So we get our two solutions. X equals 3 plus 1 is x equals 4. And x equals 3 minus 1 is x equals 2. So those are our three methods for solving quadratic equations. We have factoring, completing the square, and quadratic formula. All right, these two strategies, completing the square and quadratic formula, these always work. These always work. These two methods always work. How do I want to show that? I'll just write it like this, I guess. This always works. This, completing the square, this also always works. You can use these two strategies to solve any quadratic equation, all right? But these are not the easiest to use. If it's factorable, you want to be able to factor it, all right? But not everything is factorable. So I'm actually going to circle these two boxes over here, and I'm going to say, unfortunately, not every quadratic is factorable. All right. So up there, that top half, those are the ways we saw to solve quadratic equations. Factoring, completing the square, and quadratic formula. All right, on the bottom here, we're going to be talking about our quadratic functions and the different ways we can write them. So down here will be quadratic functions. And really, I'm just interested in their different forms, if that makes sense. So one form we can have a quadratic equation in our quadratic function is in standard form. So an equation in standard form looks like y equals ax squared plus bx plus c, right? Where a, b, and c are just numbers. And that's the one we're most familiar with. It's the one we started with. So whenever we try to factor or anything like that or use any of these methods, right, we want to get a quadratic equation in standard form, right? And also equal to 0 if we're solving. So yeah, let's use our same example from above, except instead of it equaling 0, I'm going to make it equal y. So it's an equation. So it's a function. Y equals x squared minus 6x plus 8. All right? And when you would want to make this equal 0 is if you're looking for the roots, right, or the zeros of this function, the x-intercepts. So that's when it would equal 0, and that's how we could solve for the roots or the x-intercepts or the zeros of a quadratic equation. So that's standard form. All right, we also have factored form. All right, and that is when we factor it. So that's why I circled it with this box, because not every quadratic is factorable. All right, this guy over here, though, that is factorable. So when we factor this, what does this become? That's going to become y equals, well, again, what multiplies to 8 and adds to negative 6? That is negative 4 and negative 2. So that factors to x minus 4 times x minus 2. And that's it. That's factored form. So we would use the factored form to get the zeros, right? If we set it equal to 0 now, those are our zeros, are the x-intercepts of our function. Right, so the way we go from there to there is by factoring. And we would use this to use this form to find or to solve for, actually I'm not even going to write this, right, because hopefully it makes sense. Once it's in factor form, right, if we're looking for the zeros, we're going to make the y value equal to 0. So that's how you solve. You solve by factoring, right? Or you can solve by completing the square or quadratic formula. So that's how that relates to what we're doing down here, right? And what is the last form? Last form is vertex form. Right, and if you remember vertex form, that looks like this. Y equals, you could have some coefficient, and then inside the parentheses, right, that's our horizontal transformation, plus k, which is our vertical transformation. Right, we're moving h units left or right, and k units up or down. And those two numbers over here, h comma k, that gives us the vertex. Right, vertex is h comma k. And don't forget, right, it's this h, right? There's a negative in front. So for example, if it were x plus 3 in parentheses squared minus 5, y equals, right, our vertex would be negative 3 comma negative 5, right? This piece here is opposite because of that negative. All right. So how can we get this guy in vertex form? Well, let's take a look. To get our standard form equation to vertex form, we would complete the square. Right? So the first step in completing the square is to move that coefficient over. So it's y minus 8 equals x squared minus 6x. Right, we're going to complete the square again, so take half of this and square it. We said that was 9 earlier, so I add 9 to both sides. Now it is y plus 1 equals x minus 3 squared. And let's move the 1 over, so y equals x minus 3 squared minus 1. Right, and that's how we can get it in vertex form. So not part of the question here, but the vertex is 3 comma negative 1. All right, so the way we go from standard form to vertex form is by completing the square. So completing the square was also a method used for solving quadratic equations, right? But it's also how we go from standard form to vertex form. So look at that. We've done so much with quadratics, but I think this is a good summary, right? So I'm serious. Print this out and you can take a look at it for a quick example of how things work. All right. And let me just draw in these arrows here, make it look a little nicer. All right, and one more note about vertex form. Another way to find the vertex, right, is the very first way we did it is we factored it out. We found the 2 zeros, right, and then we averaged the 2 zeros to get the axis of symmetry. So I'm just going to write another note over here. I'm going to write our axis of symmetry formula. Right? We averaged the 2 zeros first, but that happens to be the same as x equals negative b over 2a. That's a formula to find the axis of symmetry. Right? So when you do the axis of symmetry way, right, we know that is the x value of the vertex, because we know our vertex is on the axis of symmetry. So in this example over here, just if I do x equals negative b over 2a, right, axis of symmetry will be x equals negative b. Well, what was the b value? The b value was negative 6. So negative 6 over 2a, our a value is 1. So isn't that 6 over 2, which is 3? And that is how you could get the x-coordinate of the vertex. And then all you have to do is plug a 3 into the equation now, right, to get the y value. Right, so you make the x value 3 now, multiply it out, and that's another way you can get the y value. Right, when x equals 3, y is going to equal 1. So that's an alternate method to get the vertex. So what is pretty cool is, if you look at the quadratic formula, I meant to mention this in the last lesson, but guys, isn't that the equation right there for the axis of symmetry? That is our axis of symmetry formula. And do you guys remember how the two zeros are the same distance away from this axis of symmetry? Right? So this plus or minus all of this junk, right? That's just how far our zeros are from the axis of symmetry, right? And one's plus, so one's going to be to the right side of our axis of symmetry, and one is minus, so that's to the left. So there's that connection there, which is pretty cool. All right, and yeah, so if you ever forget the equation for the axis of symmetry, you can actually just look at the quadratic formula, and it's right here in this piece, right? But again, you have to write it as two separate fractions, because otherwise you're not going to see it as clearly when it's written like that. All right.